we have the signal source going out, going into the DC block, into the phantom injector, and that comes out, and there's this cable join, and that goes into the measurement box. Now, I'm going to start by setting the coupling to AC. And that essentially is like adding a DC block to the oscilloscope inputs. Now I've zeroed the DC offset. So let's just repeat what we did before. This is the anti-phase chirp. So here we can see the signal, and if I increase the output, it goes into distortion. So the DC blocking effect may be causing some filtering there, but perhaps a 100 microfarad capacitor would have been a bit cleaner, but you can see that this is not the nice sine wave that we want. So let's just turn that down. Okay, that all looks good. So what happens if we insert the FetHead Phantom, then hit play? And yeah, that's not good. So what's going on here? Well, we're actually overdriving the FetHead Phantom. And that's creating this hideous distortion. So let's just check the amplitude we're putting into it. So that's around 3.6 volts. That's the amplitude of this signal. And clearly that's too much. I believe line level is 1 volt peak to peak. Don't quote me on that. Now you can see that's a pretty badly distorted sine wave. So what does this mean? I did a lot of measurements using the adapted cable we made. However, that method is flawed in the sense that we could be exceeding the voltage level that the FetHead needs. We've seen that this method can work, but sometimes we have problems if we set the output levels too high. So as long as we choose a low enough amplitude on the output level, we should be okay to go on using this method. Now let's address the phase issue. I've set up the scope to measure the time delay between the two signals, and I've set an in-phase sweep on the laptop. So we're currently on 5 milliseconds per division. We can't really measure anything. (100 microseconds). So 50 microseconds per division, and we're starting to see around 20 microsecond delay. 17, 20. So I think it's just a fixed 20 microsecond delay. I'm going to mess with the software for a bit and try to align the two channels. I've been playing around with Tenacity and I believe I've solved the problem. So you can't see anything in the low frequency if I use this zoom level, but if we go right to the end and I zoom in a bit further, you can see I've offset the lower track, which is the right track, by 1 sample period. Now what this suggests to me is that there's actually a hardware mistake within the codec chip. Based on this, the single fixed offset seems to have fixed the problem. Let me show you that on the scope. This is probably the best shot I will ever get of the oscilloscope screen, so don't get used to it. The kind of pinky trace you can see is actually channel 1 minus channel 2, and that just lets us see the difference between them, which we're expecting to be 0 because we should be in phase. Fingers crossed. So channel 2 is on, it's just in the back there. And that's it. I think we've been pretty successful. Now we've fixed the delay issue, we can make the antiphase signal. So what I've done is inverted the right track, so we should see perfect antiphase throughout the frequency sweep. I've put all of these channels on 1 volt per division, and we would expect to see the differential signal be twice as high in voltage as the parts of the signal. So it thinks there's a delay there. That's actually just going between the tracks, so that's not really a delay. And that's just because we have it in antiphase. We've made massive progress. Now we're able to generate true differential XLR. We can verify that there's no weird issues with delays in the signal, and we can see that the amplitude is not clipping and causing unwanted distortion. We also verified that this little box is useless at the moment, but I have plans to turn this into a usable XLR power injector, so stay tuned for that. The parts I have are currently in the post, but hopefully they'll be arriving today, and I'll get that video out for you soon. I want to thank you all for joining me on this strange journey, and I really do appreciate the views, likes, and comments. Thank you all very much for watching, and I'll see you next time.